Let's get this train going. In this episode, we're gonna take existing C project into a shared library. The first step is to select all the functions that we want to be a part of the public API. Then we're gonna modify the Makefile so we can compile it into a shared library. And in step 3, we're gonna create all the installation scripts, copying all the files to the correct place. Let's get going. Sup guys, welcome to today's show. So today we are going to create a dynamic library in C. And I'm not gonna create any test project or so. I'm gonna take an old project and turn it into a library. So from an existing project, I'm going to teach you how to turn it into a library. So it doesn't matter if you haven't seen the episode where I created the original thing. You can take any project basically and do this. Maybe even your own project. Okay, so what steps are we going to need to perform? First, we need to check through the code of the existing project and create an API. And by that I mean we go through the functions and decide which should be public or private. So public means that we're going to export these functions and it's going to be a part of the public API of the library. And private means that the functions are static, so not exported. When we have done that, we need to edit the Makefile so we can compile it into a dynamic library, or to be precise, a dynamically linked library is the correct wording. When we have done that, it will be turned into something like lib something.so. So is a shared library. And then we need to create installation script so we can install it globally on the system. So the user should just be able to run make to compile it and then make install, or if it's a Linux or Unix system, sudo make install. And this can be done both in Windows. In that case, it will be turned into a DLL instead of an SO, but it's going to work the same. So this is the general idea. And the project I'm going to choose is one of my latest ones. But as I said, you don't necessarily need to have watched that episode. You can download it from the repo. So I'm going to use the TCP server. And here on the repo, which I'm going to link in the description, I have this TCP server zip file. So I have downloaded that. Here I have it. So I'm gonna do unzip TCP server blah 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 and export this as my home directory. So these are the files. And if I run make, it will be compiled into a regular binary executable file. And if I run this possibly as root, okay, let's see, maybe it's running already. Kill all TCP server. Okay, so now it's listening to that port. If I connect locally to port 8585, it says welcome to server, and if I type anything, it receives that data and closes the connection. And if we open up this directory, so let's see, code and TCP server. And while it's downloading, I'm gonna take a sip of water. Alright, so this is the code, and we need to decide on the public library. And in order to do that, we need to define, you can see as when I coded this, I already chosen some functions. And inside of the .h, I create definitions for public and private, as well as the initializer, or the constructor, which is called here. So for the public, I have set an attribute, visibility default, which means that it is exported. And I have defined private as hidden and also as static. And then I have created another attribute which I call init, which is a constructor. And I'm going to show you what that means. We can even start in that direction. So if we search for init, I have defined one of my functions as init. And this is the start function, where I initialize some global variables. And this function will run when the library is loaded. So usually that means when the program which uses that library is starting up. So here we can put some stuff that needs to be initialized, because there's no main function in the library. Currently there is, though, because I have this example code, this right here, but we need to remove the main function. So let's just comment this out. Like so. And let's check the H file for the different functions that we have. And I have the following convention, that temporary functions that's not going to be used at all, I put a space in front of. So the main and the handler is not going to be used. So let's remove the handler as well. And this is the one. Alright, so then we can remove both of these here. So that's the first step. And then we'll just go through all the functions. And as you see, I have already done that and made them private. So maybe I should move this down like so. and I am only going to export one single function as a part of the public API, and that is this TCP server function, which creates a TCP server object. And that object, on the other hand, as you can see, has a couple of functions inside of it, a couple of methods. But I have defined these as private. I think that is going to work. I'm not 100%, so we'll see. Because we have these function pointers pointing towards them, so they don't need to be exported, I think. Okay, and we need to put the private and public tags both inside of the H file like this, and on each and every function like this. And also, I have two global variables, and they are also public. So we don't only use public functions. We also need to provide which functions, which global variables which is going to be public. And another thing which is also going to be public are our definitions, our macros. So basically I have these typecast macros, and I have this return error function. And then all the structures and so on and so forth. Because this TCP server.h is going to be included when the user of this library uses this library. So they are too going to include this file, which means we need to install that as well. Okay, so that's step number one, deciding on the public functions. So let's see. The next step is compiling it in the correct way. So let's check the Makefile as of now. The only thing I have is optimizations and error reporting, and this is an important thing, the dash big I dot, because this says that we can include things in the current directory. And why do we need that? Well, the TCP server.h, when we compile the library, is going to be in the current directory. And we want to include it like this, and not with quotes. Alright. And currently we have a binary executable that we are compiling everything into, but that's not what we want to do. I'm gonna add another variable, and I'm gonna call it LD flags for Lincoln. And I'm gonna change this right here. So instead of creating binary like this, binary executable, it's going to be called SO. You can use DLL if you're on Windows. So what are these LD flags? Let's add them here so we don't forget that part. LD flags. Well, we want to compile it into a library, right? Which means it's going to be shared. It's going to be let's see here, dynamic. And we also need to add LDL. That is the dynamic link in runtime. And possibly we're going to add fpic for process independent code. And that's it, I think. So let's see if we can recompile this thing. So let's first make clean. By the way, we don't need to have this, we can change it to the SO file. So let's see if it compiles. Undefined reference to main. Did it update correctly? Yes, it did. Let's see here. Shared dynamic LDL fpic. Did I forget one? No, it should be all right. So why does it want a main function? Wait. Aha, okay. I forgot one thing. We are still creating the TCP server in the all here. We need to create the SO instead. We make. And this time it went better. It complains about a relocation instead inside of the text segment. I'm not sure if it's going to be a problem. We need to think a little bit on that. But it did create no, wait. I forgot to change it here. I'm going to add so it uses the output here instead. Alright, so now we have a proper SO file. And if we do file, TCP server SO, we can see that it's a shared object, dynamically linked. So we can do LDD, TCP server.so, and we see that it uses this right here, which is the dynamically loaded runtime. Okay. So what's next? Let's see here. Maybe, by the way, we can also do strip. So we clean out the symbols that we don't need. Right. And we can run nm on the TCP server.so. Let's see. Should it really remove all symbols? Maybe we can wait a little bit with this strip thing after all. So if we check nm now, we can see our different functions and some other stuff. So it's important that our exported functions are in this list. And as we can see, it's there. And if we take one of the other functions, so let's see, for instance, let's say the OK function. We see that it's a small t here. And if we check our start function, it too has a small t. I'm not sure if that's a problem. Probably not. Because I made that private. But it should work anyway, I think. Maybe we can take a look at that if it doesn't work later on. So let's make clean this thing and go back into our Makefile, because we need to think about the naming conventions. I want to call this, well, the goal is that when the user uses this thing, they are going to include, let's see, TCP server. So let's say ts.h. And compile it using GCC. This is when they compile their own program, which utilizes this library. So let's say we have my project.c, and we specify the library by doing -l ts in this case. And let me just double check that we don't have any conflicts. So I'm going to run ldd on bin ls, so I find the correct directory. And this is the directory where the libraries are. And as you can see, there's a lot of different SO files in here. And let's see if there is anything called TS. Let's see if there's anything called libts. Nope. Which means we can use that, because it needs to be named lib TCP server. So let's change the name like this. Let's also do ts.h. And I will just make a copy of TCP Server.h to ts.h. Let's also check the include directory, by the way. So let's see. I think it's just user include. And is there a ts.h? No. And inside of the i6, no. x86, no. What's it called? i3. There it is. ts.h. Okay, so no conflicts. That's good. So first of all, we need to figure out where we are going to put the files. So I'm going to create a small bash script which does that. Let's call it find lib dir.sh. And I'm going to use the same trick as I did. So first of all, let's see where LD is located. So I'm going to run type LDD. So user bin LDD. And if we run it on bin ls, so almost everything uses libc. So we can grep for this line. So grep libc.so. And then we need to cut this part. So 1, 2, 3, the third word. We can use awk for that extent and print the third one like this. And then we need to get this part. And I think we can do, there is a command called base dir. Or what's it called? Base name. So if we run base name on a path, we get the name of the, let's see here, we get the file name without the rest of the path. So we can do something like this. So the whole path is equal to what we have right here. So let's do the same. We will set small path with small characters. Maybe it's case insensitive. Let's call it P, so we don't mix it up with the other path variable. So if we echo $P, we have this. And let's say the base file is equal to, and we run user bin base name on the $P, and this is our base file. So our base file is equal to user bin base name of $P. So now we have a variable containing the whole path. We have a variable containing the file name. So now we can just search and replace for this file name and remove it. So we can do something like base directory, and we run sed, and we want to search for our base file and replace it with nothing. And we're gonna use our P as input. And that did not work. We need to use regular quotes, otherwise it will not evaluate this variable. Okay, so here we have found the library path. So our base dir equal to sed, and we search for our base file, change it to nothing with our P as input. Okay, so now we have maybe we can call it library directory. And now we can just echo library directory. So if we run the script, okay. LDD missing file arguments. Oh, I need to provide the ls. Okay, so now we have a script to find the library directory. So let's go to our Makefile and we will set our library directory to, I think we can do this. Maybe we should do that. Let's do it inside of the install script instead. However, we can create one for the include directory. And that's the user include file path. This might need to be changed on Windows to, I don't know, maybe you can use this path. Alright, and let's add this slash as well, because we will have it when we deal with the library path. So let's create a new rule, which is called install. And let's see here. We need to have some kind of check if if we are root or not. So let's see. We can run user bin ID. And that gives some output, but if we get the first word, and then we get a thing after the equal sign, so we can do something like sed, and we will look for let's see here. We start with the start of the input, where we search for A to Z, and then the equal sign. And then we have a couple of numbers. And after that we don't really care, so let's just do this. And we want to take out these numbers. So let's add parentheses around it like this. And we want to search and replace, so we only get that. Something like this. And it didn't work. Do we need to add extended? No, that's not it. So what am I missing here? Maybe I shouldn't escape this. Okay, we don't get a hit. So A to Z. Maybe we should have star here instead. And here. Okay, this worked. So let's remove this ABC. So this way we can get what ID we have. And if the ID is 0, we are root. So that's the administrator. Let's copy this thing and let's see here. So let's say our ID is equal to this. And if our ID, let's see, we can do this. So if it's not 0, then X, maybe we can add some error message as well. So to standard error, we write root access needed, run sudo, something like this. And then we exit with a 1, which should terminate everything. So something like this. Let's see if it works. Unterminated quoted string. What did I do wrong here? Because I think I copied it exactly as is. Let's change it to double quotes. What am I missing here? ID is equal to dot star. Let's see. If I copy this whole thing, or maybe even this part, here it seems to work. Is it this maybe? What if we echo this ID? What does it say then? Maybe it has special meaning because we're inside of a Makefile. Yeah, that's probably it. What if we were to do something like this? Will that make a difference? Maybe we need to say something like eval. Separator. Is it even possible to use bash like this? What if we were to just run ID like this? So how do we execute a bash thing and get the output back? Let's go to Google and search for Makefile functions. Call. Shell. Okay, that's probably it. So let's say something like this. And we need to update this as well. So if shell let id, something like this, I guess. Okay, so maybe something like this. Maybe something like this. Let's see how the if works. Oh, if each. Okay. So if each, and we provide our ID. If it's equal to 0, and if something like this. I think this is going to work actually. If each, no such file or direct. I think we need to put it like this. If each, blah blah blah, GCC. Maybe we need to have an else. So if it's equal to 0, then we echo OK. Otherwise we do this. Oh, we should have a parenthesis, not a dollar parenthesis. Recipe commands is before first target. Okay. Foo objects. If each to do and if. Let's put it here instead. Recipe commands is before first target. It's weird. I think I do exactly as I do here. So why doesn't it work? Oh, wait. What is this? That shouldn't be there. What if we move this up here? Huh. Okay, that's good. And what if we run sudo? Huh, nice. But I want to echo these things without double echoing it. Can we do this? Huh. Nice. Alright, that's good. So, how do we install this thing? We need to, so let's see here. First we need to make install dependent on lib TCP server.so. And what do we want to do? Well, we want to copy our dependency into our, let's see here, our libdir, which we haven't yet defined. So let's do that. Our libdir is equal to, and we want to run the shell command find libdir.sh. I wonder if we can run multiple commands, because I want to change mod it as well. Something like this. Then we can copy it to the libdir. We also want to copy our let's see here. We want to copy our ts.h to our include directory. And that's probably it, I guess. So let's see if this works. So first we run make. So now we have our SO file, but also our ts.h. And now we try to run make install as not root. And then we get the error. So we run it as root. So if we check this directory for libts, okay. Oh, I called it TCP Server here. Alright, so let's see here. So let's say this is libts.so. Let's also change the name of the target to libts.so. Same here. And by the way, after we have done this, we want to run ld-config, so we update the stuff needed for libraries. And let's see if it works if we strip it. Alright, let's try this again. So make install, and we check this directory for libts. Okay, so now we have this file here. And what about our H file? Seems to be there. Okay, so now the library is installed. Now let's see if we can test it. So let's create some temporary test file. Let's call it my project.c. And we want to include ts.h. And let's copy this. So this is the handler function. And let's also copy the main. Something like this. Let's also create signatures. So private void handler prime, which requires a connection star, and also an We don't need to bother with private, by the way. Int main void. So something like this. And let's see if we can compile this the way I want it to. And let's copy it to another directory so we know that that works as well. And let's see if we can compile this thing. So run gcc on my project.c, and we add, let's try first without adding the library. Okay, so undefined reference. And if we add -lts, LTS, then it compiles. Very interesting. And if we run my project, listening to port, ladies and gentlemen, we have successfully created a dynamically shared library. Not bad, eh? So, I hope you liked this episode. Don't forget to like and subscribe. It means the world to me. And thanks for watching. Thanks for today.